Hi, Jennifer Love. I've got about 20 years of experience in IT, OT projects, selling them, delivering them, you name it. Yeah, so I work at KBC and I'm based out of Houston, Texas.
Good morning, everybody. My name is Pablo Montaña, also from KBC. I work together with Jennifer here. My expertise is not this area, but I'm interested in learning how everything works.
Pasquale Paolone, working for Yokogawa, Exa Quantum Sales and Marketing, so data historian.
Hi everyone, I'm Barbara. I work at Braskin. I am a chemical engineer, but nowadays I am an automation coordinator, and I lead a team with 3 engineers at Rio de Janeiro.
Excellent. Michael Canellis at OSIsoft, and Mahendra, I'm intrigued on learning about the TCO and how that breaks down, because that's one of the tougher numbers to get.
Dave Espy with Air Products. I'm part of Operations Excellence, and part of my team's role manages all our historian data for the global operations piece.
Julie Smith with DuPont. I'm in our central engineering function. We're trying to figure out how to work with our IT friends to set up some sort of a data infrastructure that can work with all our different systems, from control systems to data historians to everything, without having to standardize, because that's never going to happen.
Hi, I'm John Cooley with Procter & Gamble Engineering, Fabric and Home Care, or the soap side of the business. I do process automation across all the categories and regions within P&G.
Nobuki Ogura, I come from Hitachi Japan, and I work for Hitachi Limited. My engineering sort of background is on thermopower plant control.
I'm Tom Fisk. I'm with Yokogawa, and I focus on IT/OT convergence.
So what do we want to talk about? People ask us to decrease the time to acquire more data.
I think it's on.
And to storage more data. And we know that this is not the idea for Pi. We use Pi, okay? Is OSIsoft developing anything to reach this expectation for the users, to have something that because nowadays they don't want only to see the equipment, but they want to see the instrument, the transmitter. So is there something that you are developing?
I mean, I'd be happy to talk about that. Maybe we can talk after about that. Yeah, I don't know that everybody wants to have that conversation. Anybody else? So I presented a sort of a general, right? So you should think about this, you should think about that. And then Mahendra presented, so here's what we're doing, right? An example. What do you want to talk about? Do you want to talk about generals?
I'd like, there's a theme that both of you had. I think people can hear me.
Sorry, they're recording.
Yes. All right. I think there was a theme that both of you had around structuring the data and all that. To me, it's very fascinating.
You're not up.
I'm not on.
But you're holding the. We got you to hold the mic though.
Data structuring, it seems like a difficult task or an essential task. My IT resources say just throw the data up in the lake, and then a data analyst will use 9 or Python or R, and they'll take care of that. Yeah. And I'm dubious about that approach. So if you can comment on what off-the-shelf tools are available to do the data structuring, or is it a roll your own kind of thing?
I'm sorry, do we have everybody speaking to an online please for the recording? We're trying. We are trying desperately.
Does this work now?
Yes,
All right.
you're on.
So I guess to build on that, you're lucky you have a lake. We don't even have ponds.
We have streams.
Maybe a puddle or two. So that's where we would think logically to get started, how does one do that? And my preference actually, do we have to even build it ourselves? Can we hire one of you all to do that for us? I'd just as soon not have to put like physical servers at sites anymore. I mean, that's just a waste in this day and age, but that's what we end up doing because we don't know how to do anything else.
I was just going to say, yes, I mean, companies like the one I work at KBC have invested in infrastructure to do just that for you. So there are companies out there that help you and put data up in the cloud and then work with you to understand, what you want to display, what kind of analytics you want against it, how you want to use it, those kinds of things. So those companies are out there.
Well, so let's just for a minute. So let's talk about data structure. So when you say data structure, so back to sort of the point that I made is that you've got some, if we're talking time series data, right, coming off your machines, you've got some timestamp, the asset, whatever it is, right, the machine, you've got this attribute, and then the value. Well, I was going to start there, right? I mean, the historians, the stuff at the machine level, this is generally what it's collecting. I'm just saying. So, right, so this is what you've got. And if you've got a historian, you got Pi or whatever, Yokogawa, et cetera, that's what it's going to, that's what the machines, the PLCs and so on are going to collect. And you're going to send over to your historian.
And it's compressed also.
And it's compressed also, which was your question. Yep.
So let me just. Hello. Yeah. So you were saying to collect the data. So you're collecting the data in some machines. And then actually, like, you're extracting everything and then dumping in the data lake. That's what you're.
It's a historian first. It's coming from.
Yeah.
Already in a historian.
Okay, it could be a historian or it could be a streaming data, and then they are saying actually to put everything in the data lake, and from there. So that when you say historian, is it going to be a one-time load, or will there be a continuous?
Hundreds of historians scattered across the globe. They're all wonderful historians collecting
Okay.
thousands of tags at one second. Vast amounts of volumes.
And they are staying in the same size, or they are also expanding?
Right now, they're local, on-premise, everywhere.
Okay. So you will have actually historian streaming and batch modes and the static historians, all of them actually, all kinds of formats you have.
It's all in the local historians.
Okay.
The question is how to get it to the lake and how to structure it so that somebody can make good sense of it.
Right. So I can speak from my experience. So we have similar ones. The streaming historians and as well as actually history data actually we have accumulated over years. All of that actually lying there in the on-premise, and then we took it to data lake. But when we took it, actually, it's not like, what your data engineers are actually suggesting you is ELT model. So extract, load, and then transform. So which means you go and structure it in the data lake using Python and all the Python libraries, right? That works. But will it be sustainable? I doubt. Because when you have a streaming data coming out, and if you can actually, to an extent, structure the data over time, once they structure it. So that's a one-time task, right? And then the result of the structuring is a data catalog. The data catalog, you have to maintain it, and then that data catalog, using the data catalog, you have to form a data governance policies. And then you have to federate that governance to both on-premise as well as cloud. Because you cannot actually simplify the solution like, I would continue to create garbage data or unstructured data and then keep on relying on a data lake solution. Because over time, when your data volume goes up, this is not going to be sustainable. So you have to have a data governance policies. Once you structure it, probably that's the first step. And then once you structure it, create a data catalog, and then federate that data governance. So tell all the individual sources, okay, how you have to structure your data. So over a time, the transformation, compute loads here in the cloud will reduce, because it's not going to be easy. What happened was, one example from my past is, we have a streaming data coming from machines. And that streaming data, we were just uploading it to cloud, and then the cloud will actually structure that machine log. So how does it structure? It's a serverless function in the cloud. Actually, every 1 hour, actually, the program keeps running. Cloud vendor would charge you for every time the program runs, because based on the workloads. So what we have done is, we have started doing labeling, actually, and before even actually we sent it to cloud. A very small step, but that very small step reduced our billing actually at least by 15%, what we used to pay to cloud vendor. Those are the next steps. What you're talking about is just the first step. We have to do it because we have to get these data connected. You don't have to really actually move all the data to data lake to structure it. Maybe you can take the best sample size and then structure it, put your data catalog, then actually structure the data at the source as much as you can. Of course, you don't want to actually hire more servers in your on-premise.
What kind of tools? These off-the-shelf tools, custom programming concepts? How do you structure it?
So most of them actually, Python is actually one popular tool, and we have actually package solutions as well available. It depends on actually how much you want to spend, and it depends on your IT's competency, where they are from. Because today there is no real limitation, it's available only in Python or Java. Yeah, there are many, but in my experience, we have used actually a lot of open source.
So you roll it, you build your own data governance, data conversion.
Yeah. So Informatica is one platform which has it, but I'm not sure OSI, you have data catalog and governance solutions, I guess. So yeah, every company has, but we have actually leveraged open source a lot.
I'm trying to keep it general versus, just buy our software. Yeah, neither. No, none of us. Yeah, we're not trying to. I think the point that perhaps we're trying to make here is, and you are too, is okay. So you've got all of this data sitting in your historians, and you got these historians all over the place, right? And to do something, not just to have the operator sit there and make some decision, which is what you're doing today, and also some people pulling it, you need additional information, or you need to match it with some other systems. You need to add, we call it context or whatever, but you need to add more stuff. So, Mahendra's saying, okay, so you're going to take it to the cloud and you can do stuff, the data lake. The point is, whether you're going to do that here or you're going to do it here, at the not at the historian level, but perhaps at a intermediate system that takes all of that and puts it somewhere. But on the manufacturing side, not on the IT side, or on the IT side, you're going to need something that's going to do that. Clearly, you need to think of that. Some people are saying, let's take it all to the data lake. So then if that's what you're going to do, then you're going to need somebody over here to add that context and structure to that data. And if you're going to do it over here, you need somebody to do it. Same thing. It's just where you're going to do that.
And the other piece that's in there, which you mentioned, is the governance.
Yeah, it's the governance. Yes.
It's the governance piece.
Right,
and
same thing.
Not governance as in an application that's doing it, but someone needs to own it, because all that context comes from the subject matter experts.
Yes.
Right? It's not an IT thing. It's the subject matter experts, and so you need a process in which you, often at trivial levels, like what's the stuff? What's
Expert doesn't know Python.
Correct.
What's
Yeah.
it
But
called?
but it doesn't mean that a subject matter expert has to, but he'd have to work with somebody who does know Python.
How quickly, what's the sample frequency
Yeah.
associated with something that's meaningful for the subject matter when they pull it back out. So if it's a machinery engineer who's doing doing startup profiles, well then that's 1 second data. If it's a process engineer on a distillation column, and it's hours that he's worried about. But it's that governance piece which is also critical in that whole process of where the data goes.
So not to talk product per se, but so historians started out as collecting all of this data, so now some have developed this additional capability that provides this structure and the ability to put in the metadata associated with it. So that's one way to do it, is to have that here in a system that, you know, aggregates pulls all that data and does some of that structure here, and then you take over to the data lake whatever you need to, but it already has the context. And, you know, there's one school of thinking that's a good thing to do, because then you've got the process engineers, the people that understand the process, you're doing that closer here as opposed to over in the IT system. But again, you know, these are sort of artificial in the sense of IT, OT barriers.
Well, doesn't it also depend what other data you're pulling
Yes.
in? Like if you're pulling in
This
data
is a
from
good
SAP,
question.
that's over on the IT side.
That's over on the other side. That's exactly correct.
Right, or customer complaint data
Yes.
coming in through, you know, SFTC.
Yep, it does. Yeah, so again, I think that this is another consideration, is as you start thinking of this, the scope of the decisions you make are getting bigger. Because if you're going to start to pull in the SAP data, now you're pulling in customer information, now you're pulling in a lot of information that you didn't have before that you could easily tie in with your operational stuff. So there's at least, in my mind, at least two considerations: is what are the operational type decisions you want to make, operators, process automation, et cetera, and then what are the bigger type decisions you want to make with your IT stuff. And the example I give is, you know, so you're looking on the historian side and you see the motors are degrading, the performance of the motors, and you've got that data, but you don't have any idea where you bought those motors. You can't easily get that information, and maybe you bought a bad batch of motors and 8 of those, you know, 10 in that same order were bad. You'd need to tie those two sides of the data together, right, to be able to solve that problem. Whereas on the operational side, you'd be looking at it thinking, oh, it's the motors right there, and I need to replace them, when in fact it was really, those are the kind of, right, the scope is going to be much bigger, and you're going to need a lot more data to be able to solve that type of problem.
And whatever integration pattern, actually, you know, whether you're going to parse and structure your data at the edge or at the cloud, anywhere, but it's not going to be the de facto design forever. You will change it. You will change. You will keep on changing it. But the data governance piece will make sure, actually, you know, you have that flexibility to change whenever you want to and wherever you want to move to. And this data, once you structure, is it going to be the same size and format actually it's going to be in? No. There will be more and more other sources actually would be coming in and enriching this data and enhancing or maybe transforming the structure even more. So that is a continuous process. So the data governance piece is very, very important, because otherwise somebody build a data lake. Over a time you would hear multiple data lakes in one enterprise, and each of them will have their own structure, and if one engineer leaves, that's it. Nobody will be able to understand what the data lake holds. So that's where you need to think about data governance piece well in advance before even you put your foundational architecture. Yeah. And it actually helps bridging the gap between the subject matter experts and IT, because it reduces the conversation. So subject matter expert would say, this is the data set I'm looking for, and that's it. And you know, engineer actually has a good starting point to move on. And then actually they can have a very productive discussions when they meet again.
So maybe that's a thing to think of, is to think of, you need a data governance strategy on your operational data. And again, if we're mostly sort of on the OT side, IT has done this. I mean, right, they generally have data governance strategies, and they've been doing it for a long time. But we don't see much of that on the OT side. And so, you know, you mentioned you have all wonder where, yeah, it's not usually the case that it's all anything. it's usually the case that there's 2 or 3 in a company because of divestitures and, right, and you bought a company and they got something else and so on. Yeah, right, you name it, yes. Equal opportunity, yes, yes, purchasers, right? And you don't, and when you buy it, you don't know which one's gonna, you know, survive or be the big one. Anyway, it sure sounds like that there's gotta be, when I say data governance, I don't know, you know, how strict, but some sort of idea or, right, you've gotta get some strategy around, so how are you gonna manage this operational data? And, you know, how are you gonna manage it? You know, who's gonna manage it? And then how are you gonna make it available for other systems? And I suspect, you know, I said it in my presentation, I suspect the majority of this is somebody comes to you and they say, I need some data, right? And somebody writes a program, you know, to do it. And that's how you get it done, but that's not, it's, well, it is sustainable because we do it, but it's not really what you want to do. Yeah.
Someone collects it in Excel.
People want to apply it to flow to the historian, and it works, but the data's not structured in the right manner. Make the slicing and dicing the data
Yeah.
very easy.
I want to be able to analyze data by different lines, by different shifts, by
Yes.
different formulas, by different bottle sizes, by different portions of the equipment, and slice and dice it every which way. Theoretically, Tableau can do it directly against the historian, but the reality is the data is just not structured, not normalized sufficiently to do that.
And in fact, who even knows what the tag names mean? Very few people. Correct. So again, just at a generic, without, you know, saying buy this or, you know, you should think of somehow adding, I believe you should think of somehow adding structure to that data. And you can do it on the operational side or you can do it on the IT side, data lake, whatever that is, but somehow that's got to get done.
And security, it's not mostly spoken of loud in manufacturing, but in the internet e-commerce era, GDPR in Europe, or even there's a new law coming out in California for the information security. So all of that actually makes it even more complicated because manufacturing world is not exposed to cloud so far, not a lot. But when you take this data to the cloud, you have to be aware of all of that because the Python developers, data engineers you're going to work with, they will be creating microservices and programs running. So what are those programs? So you will not have a physical server owned in your name. There will be a serverless functions. How your cloud vendor is going to deal that data and how those serverless functions are going to work. So you have to be aware of all of that. And the data governance will be able to help you if you want to prepare for such a storm like GDPR comes in. You will be scrambling. What data I have, and how this data is going to be a concern for compliance or legal requirements. How am I exposed? Even look at Facebook or anyone. If you look at actually do the postmortem of what they have done in 2014 to 16, people didn't even realize. In one words of those executives, they didn't realize that actually how these data will be used, right? So you have to have this governance. It'll also have the security, covered. Any other questions?
I'm actually kind of interested actually from the three of you, where do you think it makes sense actually to do more of the structuring on the local end or up in the cloud? Because and what factors would go into it? I mean, does cost even come into it, or?
My head around, I don't know. I've heard people say you need to think about it. I'm thinking about it, I don't know.
Right. So one easy thing is if you do not have a streaming data coming in a lot, if you have only batch and just a one-time load, go for it. Dump everything in data lake, and then you can start parsing the data. Why I say that? It's a very strong opinion. I may be wrong, but I'll give you my considerations why I say that. In cloud, it has enough elastic computing power to deal with large data sets. What if you want to do this one-time data parsing in your data center? You have to add a lot of storage and compute. Are you prepared to do that capital investment? No. Then go with data lakes. And then keep in mind that is only the first point. The second step is you have to immediately, the result of that data parsing has to help you create a data governance and data catalogs. After that, start monitoring the workloads. That will tell you eventually, okay, how much money you are spending, and based on that, you will actually make additional investment in your edge, which will help you reduce the overall cost. So you cannot really set a goal like, okay, I'm going to do this architecture, and the ROA itself, actually, it will be evolving. All the software vendors now moving from capital investments to operational expense models. So you have that advantage. So you can take that advantage and then go to cloud and then decide your long-term architecture eventually. It's easy to start in cloud. That's my point of view. That's what we did. We did with like a couple of engineers to start, and then we grown. Yeah.
Yeah, the challenge, and Air Products is a little bit unique in the sense that we have a large number of small facilities, right? So we've got now, several years ago, we made a strategic decision that says every plant is connected to the historian. So we have literally hundreds, we have probably 800 or 900 individual plants connected, right? So, and we centralized our historian. So in a sense, we created a cloud environment, a centralized data environment. Most of the work is not in the IT piece of where you do the structure. It's getting consistency in the subject matter experts and this governance piece of, for us, there's almost some trivial issues like, what is the plant called? Yeah. Right. So,
what is uptime? What is uptime?
Right.
What's utilization?
What is it? We have a plant. We say, okay, we're bringing data from 1,000 plants. Well, what is the name of the plant? Right. So it's very quite sounds like an obvious statement when you have a very but that's the sort of thing that becomes the issue when you then go, okay, I have all of this other application environment that is pulling the data. And whether that's a cloud and a lake, or whether it's, for us, we have a centralized IP21 instance, but it's the same use case issue of how I go use the data. So that's my only comment is, and if you want to kill a good party, you start talking about data governance to people, and it's like, it's like, I gotta go have a root canal. Right? That's a really exciting topic, right? So that's my only comment, that having some thought process around that and structure and how that's done is probably, it's often more important than the application of the tools that we.
I guess we would apply the SAP functional location codes kind of concept to structuring when you structure the data. So every tag has to come from a certain plant code and a department code and process area code.
And the challenge is that the SAP functional hierarchy means something to the people who are using SAP, which is primarily the transactional maintenance people.
The finance, maintenance, purchasing, yeah. Nothing to engineers, yeah.
That's what comes up when you start going, okay, in your case, I've got, I wouldn't put any individual parts that I want to compare. That's a big challenge.
Again, without saying whatever I think the answer is, what we see companies doing is setting up these hybrid structures like you were talking about, right? Where they say that some of these decisions are going to get made at the operational level, and so we need to have the structure in the organization at the operational level, but we're going to have to pass whatever amount of this data into the IT world, let's call it for now, so that bigger type decisions can be made, and that's going to go most likely into the cloud because we're going to, pull in, you mentioned the element analytics, we're going to want a third party to come in and apply some algorithm that they've got, and we want to make that easy, and the easy way to do that is in the cloud, because otherwise, we got to spend a lot of time figuring out how to get them the data and so on. But it sure seems like a hybrid structure of we're going to do a bunch of stuff, whether you call it on-prem or not. Your historians are on-prem. They may or may not go into the cloud, but that data is going to move from those historians perhaps into some operational system where you do your operational decision-making and your operational analytics, but yet it's going to have to move over into the IT side, which, again, depending on the IT strategy, is going to go into the cloud. And even on the operational side, you might move some of that data into the cloud because you're trying to solve some, some problem that's not necessarily an IT issue.
We keep no data in the cloud because we have no people there, right? So we can't be rebooting servers and backing up and that sort of thing.
So,
No. So we have because of our business where we have all of these small plants, right? We've worked to the case where we have a centralized historian infrastructure. So the servers and the databases are in centralized data centers, right? And we don't keep data on the site at any of the sites because we don't have people there. So we certainly don't have an IT infrastructure organization in those sites. So our historical experience was they didn't get patched, they didn't get backed up, and you lost the data. So that was kind of why we went to that environment.
Yeah. The problem is the sites, they might not have the people, but they don't want to give up the control.
So so it's interesting in this discussion, right? The biggest change is actually is not moving data to the cloud. It's moving it off the site, right? That is actually not important. It's, to your point, it's the cultural point of this is our data. And it's our data. It's not your data. It's our data, right? And it's that cultural. That's part of the governance issue, right? It's part of the cultural change.
Yeah, in this digital transformation IoT journey, right? First, most of the use cases you would like to solve, you would have seen that theme in most of the presentation. Is first you start with descriptive, diagnostic, and then predictive and prescriptive. So you won't get to the predictive and prescriptive immediately. So first thing is descriptive and diagnostic. That's what your first goal is. For that, what do you need? You need you're actually doing a postmortem analysis. So an incident happened, and then you're actually trying to make create some insight out of the data which is already generated. You're not predicting or you're not advising, how the machines in operations should work. So, given that, it's a postmortem analysis can better be done in cloud. It depends on actually how much money and what is the latency and stuff. But latency will not be a big concern when you go to the very first two phases, like descriptive and diagnostic. Latency will be a concern when you go to predictive and prescriptive. That's when you need to start looking at the architecture more closely. But when you're setting up the architecture for first two use cases, you should make sure the latency, your architecture is scalable. That's when you would make additional investments in your edge. So it's not just going to stay in cloud. Predictive, if somebody says we can make predictions in real time from our cloud platform, that's a lie.
What else? Not that we've solved.
What I'm thinking is we could probably get together, you and I, and kind of come up with an article and, jointly write something and maybe address some of these issues, around the data structure, the data governance, and also around, I guess, moving the data to the cloud. And I don't know if there's any other issues that you wanted to talk about before we go. We only have a few more minutes, so.
I mean, people are wrestling, everybody's wrestling with this. If they know enough, they're wrestling with this, right? Some are just forging blindly ahead, and then they'll figure out that, right, that there are some considerations. But it's, we talked about, security and so on, and I was talking about the quality of data. I mean, these are all the considerations you've got to think of. But as I said, I think also, and Mahendra mentioned it, it's the type of decisions that you want to make too. So think of those types of decisions like an operator sitting here, or a process engineer wants to do this, or somebody from IT or whatever the business side comes and says, hey, we have this problem. And if you think of a number of those scenarios, I think that'll help you also with the architecture in terms of, as Mahendra said, it's not likely that in real time you're going to fix a problem with the thing going up to the cloud and some predictive model. It's just not going to work that way, right? And if you at least figure out several of those, and maybe you won't, it won't be apparent of what the answer is, but it'll be apparent what the answer isn't.
And I thought we had some really good insights. I don't know if you want to say a few words before we close.
Yeah, I think in the previous the presentation, actually, before this meeting also, someone asked, actually, where do we start? How do we identify the opportunity? I think you can start anywhere, if you ask me, because the very first time I actually demonstrated, okay, this is the capability we can actually pursue, I didn't even realize that that was the use case I would end up implementing. Someone else got interested, and then actually we implemented in a different area. So your IT and manufacturing, or any business group for that matter, they have to work together. The IT comes with the capability, skills, and stuff, and it has to be complemented by the the SMEs and knowledge and industry knowledge. That's when you'll be able to achieve this. So you have to bridge your gap between your manufacturing business and IT. That's when your digital transformation will become a reality.
All right, well, thank you very much. And if there's any other questions or anything, you can email us, and we'll try to put it all into a little report. And we do appreciate everybody staying to the end. And I hope that it was worthwhile for you. And I think we had some really people with a lot of deep domain expertise up here too as well. So I really do thank you and appreciate it. And even in the audience, we had a lot of domain expertise. So thank you. Really appreciate it.